the signal keeps arriving ahead of itself. That is the part the tracking models stop surviving. A pulse appears near the edge of the Oort trajectory maps. Receivers rotate toward it. By the time the arrays finish correcting position, another burst forms farther out in the dark before anything physical could have crossed the distance between them. The projections keep failing in the same direction. Out there, spacecraft survive mostly through prediction. The prediction systems begin separating from reality first. Static bursts cut across the receiver before the transmission finishes buffering. One pulse. Silence. Then the same pattern again from farther out in the dark. Deep space tracking stations begin flagging timing drift almost immediately. Tiny navigation corrections stop agreeing with each other. A probe beyond Neptune rotates 3 degrees off its expected orientation, then corrects late, as if the signal reached one system before another. Nobody understands why the delay keeps changing. The Oort Cloud begins so far beyond Pluto that sunlight barely behaves like direction anymore. Out there, spacecraft survive almost entirely through timing, position, distance, signal return. Once those numbers stop matching, spacecraft stop knowing where they are before Earth can correct them. NASA receivers record the bursts across multiple arrays. Same spacing, no measurable decay. The signal keeps coming from farther out. One reconstruction catches the static crossing a navigation clock exactly as a guidance update fails. A frozen antenna dish keeps turning slowly through darkness, while the pulse repeats underneath it. Then, another spacecraft stops trusting its own position completely. Not contact, not impact. Just navigation systems separating from reality faster than commands can reach them. A comet tail drifts sideways through weak sunlight, while the tracking grid keeps recalculating around it. The movement looks small at first, until multiple trajectories begin leaning the same direction. One outer system probe changes orientation by less than a degree, then fails to return to its original path. Hours later, another object much farther away begins drifting the same direction through completely different gravitational conditions. The trajectories stop matching the math. Past Pluto, tiny corrections normally hold for years across frozen distance. Instead, projected paths begin sliding away from the objects they were supposed to predict. NASA tracking teams replay the guidance telemetry while the transmission pulses continue underneath it. Static cuts through the signal clock. Thruster corrections begin firing after the spacecraft has already drifted off alignment. A probe silently rotates off course with no recorded system failure at all. Then the same directional error appears across objects too far apart to influence each other. Hundreds of millions of miles apart, separate trajectories begin bending in synchronized patterns with no shared gravitational cause. Return paths stop closing correctly. Interception windows collapse. For any crew that far from Earth, life support could still function, while rescue trajectories failed completely. Oxygen would still exist inside the spacecraft. Heat would still circulate through the cabin. But the route home would already be gone. Farther out, the pulses keep repeating through the dark. The pulses thin out once the probes cross a sparse debris corridor. For the first time in days, the guidance errors stop spreading. Tracking markers stabilize. Signal clocks realign. One navigation team overlays the bursts against comet density maps and finally sees something that behaves like a physical environment instead of a transmission source. Charged ice, frozen particulate streams, For a while, the ice fields seem to explain it. Far beyond Neptune, long-period comets can drift through darkness for millions of years before returning toward sunlight again. Some travel so far from the sun that weak halos of charged debris become almost impossible to detect directly. Inside one deep space reconstruction, pale particle clouds shimmer around tumbling fragments of ice, while radio pulses scatter through them in repeating arcs. Static flickers across tumbling ice fragments, then fades as the debris spreads thinner. For a while, the environment feels measurable again. NASA trajectory models begin updating successfully across several outer probes. Correction burns start matching predictions. Return windows reopen by a few critical hours. Inside a crewed vessel that far from Earth, hands finally settle against the console long enough to trust the numbers again. But something stays wrong. Random debris should create random interference. Instead, identical pulse spacing keeps reappearing inside completely separate ice fields, moving different directions through deep space. The signal weakens, then reforms farther out. The signal reforms again before the receivers finish rotating toward it. One burst appears ahead of the predicted debris field by nearly an entire orbital span. Navigation software rejects the reading immediately, then accepts it seconds later when another pulse arrives from even farther out. The signal appears ahead of motion that has not happened yet. Inside deep space control rooms, tracking overlays stop lining up with the objects they are supposed to follow. Frozen comet fragments keep drifting normally through darkness while the transmission reorganizes somewhere farther ahead. The debris explanation stops surviving direct observation. Outer solar system communication delays can already last weeks depending on distance. By that distance, crews survive mostly through prediction, long before instructions arrive from Earth. Now the prediction systems fail first. NASA timing models attempt to project the next burst location using the previous trajectories. Projection after projection begins failing. Static erupts from empty darkness ahead of moving probes before the objects themselves even enter the region. A guidance camera catches one pulse blooming across black space with nothing visible behind it at all. Another appears even farther out. Then the pattern jumps again. Inside a crewed vessel, nobody fully trusts orientation anymore. Star maps no longer agree with navigation clocks. Windows show empty darkness, while onboard systems insist the spacecraft has already crossed regions it has not physically reached yet. Hands grip restraints during routine course corrections because nobody fully trusts which direction the vehicle is actually moving anymore. The outer solar system keeps behaving normally for a few seconds at a time. Then the pulses arrive, somewhere impossible again. Another pulse appears beyond the last mapped trajectory. No debris field surrounds it this time. No comet fragments. No reflected interference. Just a brief eruption of static somewhere farther ahead, while a lone probe continues drifting outward through black space. The signal keeps appearing before the environment around it does. At that distance from the sun, communication delays stretch so long that corrections arrive after navigation conditions have already changed. By the time Earth responds, the navigation problem already exists somewhere else. NASA tracking systems eventually stop producing projections crews can safely follow. Positional certainty drops below operational thresholds across multiple outer routes.
The gyroscope is spinning,
Every probe
but
entering the
display
region
reads
begins
nominal.
losing
I
reliable
don't trust these
orientation
readings.
within days.
We need a manual confirmation of attitude.
The failures remain almost invisible at first. A transmission repeats somewhere ahead. Guidance systems adjust toward it. Minutes later, the pulse reforms even farther out, pulling trajectories deeper into regions prediction systems cannot hold stable. Inside a crewed vessel, isolation becomes permanent before anything physically breaks. Food still exists. Heat still flows through the cabin walls. The body remains alive while every trusted reference slowly separates from reality. Beyond a certain distance, nobody can tell if a spacecraft is drifting away from the signal anymore, or being guided deeper by it. Far behind the probe, the sun keeps shrinking. Ahead, another pulse flickers through the dark.